Welcome to our workshop on the principles that you can use to reduce extraneous overload. My name is Kim and I thank you for joining me today. So we will discuss 3 principles that will help you to reduce this overload. So let's begin quickly with a review of what actually extraneous overload is. So extraneous overload occurs when the essential processing and the extraneous processing, and this is referenced from the cognitive theory of multimedia learning, is greater than the cognitive capacity of the learner. And this is based on the work of Meyer and Fruella, 2014. If you reference the cognitive load theory, based on the work of Poss and Sweller, 2014, then the extraneous overload would occur when the intrinsic cognitive load and the extraneous cognitive load exceed the working memory of the learner. Extraneous overload needs to be reduced. There are numerous principles that can help in minimizing this particular load. In this video, I will focus on 3. They will be the principles of coherence, signaling, and spatial contiguity. For each principle, I will define what it is, explain its relationship to the cognitive load theory, and then give you a demonstration on how you can use this principle in your own instruction. The coherence principle states that individuals learn more deeply from a multimedia message when the extraneous material is excluded. When a multimedia message contains learning material, i.e. the intrinsic cognitive load, but is presented in a difficult manner, i.e. the extraneous cognitive load, this leads to extraneous overload. Extraneous cognitive load can be caused by such things as the font size is too small, the colors of the screen are too hard to read, the material is blurry, or there's a glare across the screen. This will lead to the demands of the intrinsic load and the extraneous load being greater than the processing capabilities of the working memory of the learner. We already know that the working memory is limited. So therefore, the extraneous load, which deals with the presentation of the material, requires processing and actually pulls resources away from processing the learning material, i.e. the intrinsic load. So this will result in a lack of meaningful learning. Schemas are not formed or expanded, and nothing enters the permanent storage of the long-term memory. The coherence principle states that when extraneous material is excluded from the multimedia message, that people will learn more deeply. So we can see by adhering to this principle, we are actually minimizing the extraneous cognitive load. We then need to make sure we're using the appropriate intrinsic cognitive load, which is based on our learners, and this will maximize meaningful learning taking place. So if we look here, this is an example of a violation of the coherence principle. The fonts are way too hard to read. There's a lot of pictures, and they may or may not have something to do with the topic, but yet they are requiring processing resources to scan and make sense of them. So these resources are then being expended on the extraneous and the intrinsic cognitive load. This is not going to lead to meaningful learning. The cognitive process is less than the extraneous and the intrinsic effort that is needed. So the same slide could be reformatted to eliminate the extraneous cognitive load, and this would allow sufficient resources to the intrinsic cognitive load, leading to meaningful learning. Another principle is signaling. This states that individuals will learn more intensely when the multimedia message contains cues. These are arrows, or these are underlines or bold print that showcase the necessary or relevant information. Signaling principles direct the learner's attention to the essential or the relevant information. This should decrease the extraneous load. The signaling helps the working memory to identify what information is important, and this will continue with the integration into the schemas and thus the long-term memory. So here's an example of signaling. We have 2 paragraphs. If you look at the first paragraph, this is just as a regular paragraph would be presented. But if you look at the second paragraph, this is when we have actually underlined and bolded some of the print, and this is the signaling. So hopefully is pinpointing the learner to the relevant information here. Spatial contiguity states that individuals learn more deeply when words and pictures are near each other on the screen or the page. The use of spatial contiguity directs the learner's attention towards the relevant information, but all in one place. And this will decrease the extraneous cognitive load, where we're not scanning back and forth between two different pages or two slides, trying to find the words and the pictures. This will make processing resources directed to that intrinsic cognitive load or the essential material, and will result in the working memory doing its job and leading to meaningful learning results. So if we look at this example here, the pictures and the words are in close proximity. It makes it easy to read, easy to scan, and easy to retain the essential information. Extraneous cognitive load is reduced. Meaningful learning will result since the working memory can identify what is important and begin organizing and the integration with the schemas and the long-term memory. So here are some of the references that were used in the preparation of this video. Lastly, I want to thank you for joining me today, and I hope that you've learned some important tips to consider when designing your courses so you too can reduce extraneous overload.